Do you have a bite king? Tell me.
No, I mean, because people have like a little nibble, like they'll nibble on you a little bit. I don't really like that much. I think that's a little weird. Then again, I don't.
What if they like bite your neck though?
Are we talking like Dracula bite? Or are we talking like,
yeah, I'm talking straight vampire bite. Yeah, like
oh well, that's
like drink
suitable.
your blood bite.
That's suitable. I will say though, I don't like half measures. Like if someone gives me a hug, I want it to be a tight hug, you know?
Oh.
I don't like loose hugs. So if someone's gonna bite me, they have to bite me.
I thought you meant like cups, like
No.
I don't like half cups. I only like cups.
Oh
like,
wait,
what?
let me move. No, let me move the mic a little. There we go. Okay. No, what I meant half measure. I did not mean half measuring cup.
Well, I'm glad we're having this conversation, but I'm recording, so
that's fine. I want the viewers to know that I
have a
don't
bite king.
like half.
Well.
I don't like half measures. You know, if you're gonna go in, you better do it. You better do it good.
Yeah, here we are. Hello, everybody. Welcome back to another lovely episode of What Do the Gays Think? Today with me, I have the gentle and hardworking Pat. How you doing, Pat?
Gentle, yes. Hardworking.
I mean, my man's a PhD man. Almost, right?
Not yet.
Almost.
Not yet.
Gotta be hardworking to get that shit.
Yesterday, both my stepfather and my mom were like, so when are you finishing your degree? And I was like, when are we, Mom? When are we?
Know. Hello.
I hate that question. For all those listening, if you know someone in any degree, honestly, undergrad, grad, like an MBS, whatever, never ask them when they're finishing.
Oh, can I ask you when you're finishing something else?
Wow, that's important. You should always know when you're that. But when you're doing a degree, don't ask them. Especially if it's like a research degree, don't ask them. Thesis writing is the worst thing ever. But we're not here to relive my trauma. We're here to talk about something today.
What are we here to talk about?
Viruses.
Oh.
Not computer viruses, because I don't know about that. But we're talking about biotic viruses.
Give me that good viral load, if you know what I'm saying. Good way to start off this episode, Pat. So, viruses, yes.
Okay, so, oh God, hold on. I'm trying to recuperate. Viruses have been in the news a lot recently, obviously, because of coronavirus.
No, you're lying. Viruses are never in the news.
And that's the episode, guys. I hope you enjoyed. Virus has been in the news a lot recently with coronavirus, and if you watch our show on YouTube, and then if you listened as well, you would have noticed that last episode before that, I talked about having a cold sore, which is also viral. So I was like, well, it's in the air, it's on my lips.
Here we are.
So viruses. What do you know about viruses?
Hang on. I'm just going to fix my camera angle real quick because I feel like it needs to be closer to me.
Sure. I'll regale the viewers.
All right, what was your question? Tell me, now that I'm a little bit closer to the viewers.
What do you know about viruses?
Very little. I've heard that they are not alive, quote unquote.
Right.
And that they just kind of like infect cells, and the cells become infected, and they become like the hosts or whatever. And then I don't know what the fuck. Yeah. They make things happen. They kill people, etc.
I mean, they do. All of those things are true, which is great. So you know quite a bit already. Yeah. The main thing everyone thinks about when they hear viruses, at least for me in biology, is like living versus non-living.
Right.
So is it alive?
Am I wrong? Is it not alive? Is it alive?
No, it's okay. There's like still discussion about it. I think they're not alive.
Okay.
So basically, biologists have come up with these quote unquote characteristics of life. And if something fulfills all those characteristics, it's considered living. And if it doesn't, it's considered non-living.
I see.
So characteristics of life, let's just run through them. Homeostasis.
Depression.
Acceptance, bargaining, the stages of grief. Yes.
The stages of grief, all of them, yeah.
Homeostasis, meaning you can regulate your own body, your own cell to keep like a steady state, to survive, basically.
What'd you call me? Homostasis?
Did you just call me a slur? I'd rather you just call me a slur.
I'd rather you just call me a slur. It's fine. Homostasis, he says.
Homeostasis.
Homeostasis, right. What is it
Um,
again?
regulating yourself to maintain like an alive state, like we regulate our body temperature, we regulate our metabolism,
Hmm.
so we're alive. The second is organization, so we're composed of either one or more cells in an organized structure. So, you can have single cell organisms that are still alive, or you can
Hmm.
have things like us, which are composed of cells, tissues, organs, organ systems, the whole kit and caboodle.
The whole nine.
Then, of course, metabolism. So you break down or build up compounds by either utilizing or gaining energy, So chemical processes are happening in your body that you can utilize things for energy, which then you can do the fourth characteristic, which is growing, obviously. So an organism's growing to a larger state, their internal components growing is considered a characteristic of life. Adaptation, so you can change over time in response to your environment. So, uh, over time, we have adapted different types of environments like temperatures or different types of external stimuli like radiation, sure.
Sure.
And then of course there's response to stimuli. So if you are a living thing and you are, touched with something hot, your body responds to the stimulus. If you're very cold, it responds to stimulus, or it can respond to like chemical stimuli. And lastly is reproduction. Unfortunately, gays can't do that, so we're considered
Yeah, we're
non-living.
considered dead.
Um,
Thank God, honestly.
God,
Bless.
yes.
God
So
bless.
we're considered non-living, unfortunately. Zombie rights,
Zombie rights. Zombies said gay rights.
Zombies said gay rights. So if you're a zombie and you have sex with another zombie, is it necrophilia?
Oh, well,
I mean, it's
I mean, you're both dead at that point.
so it is though, because necrophilia is just sex with a corpse.
Well, but if you're also a corpse, does it count though?
I don't know. That's why I'm asking you. These are the hard-hitting questions.
If a zombie, if an adult zombie has sex with a child, is it pedophilia?
Wait, is the child also dead? Because
Maybe.
then it's necrophilia and pedophilia.
At this
Pedonecrophilia.
necropedophilia.
Philia, yes.
Oh my God. Hello.
It's all wrong.
It's a no. It's a. And then what if the corpse is an animal? So then it's bestiality as well.
So let me wait. Where's my dream journal? Hold on. Let me write
Where's
that
my
down
dream
really quick.
journal?
Okay, yeah, that's gonna be in my fanfic I'm writing later. So if you have all these characteristics of life, you're considered living because biologists do not have a strict definition of living because some organisms, don't really have all of these. Some of them do, but viruses really only have one of these things, so they're definitely not living. So they obviously can reproduce. They can generate new selves, but it requires a host. Viruses cannot proliferate outside of a host. They can exist outside of a host, and they can exist for some time, but they cannot proliferate without a host.
Right.
You could say that viruses respond to stimuli by like mutating, and like there's selection being placed on viral genes to mutate or change a certain way, but I don't care about that.
Oh, let's just ignore the science.
Well, they don't have all of the characteristics. They barely have one characteristic. So they're definitely non-living, in my opinion. There are people who say otherwise. There is an interesting conversation, though, being had about whether or not viruses could be a good way to study the origins of life, because a lot of people think that, multicellular life, besides the whole endocytosis theory they have, was that you had a lot of these single-celled organisms like viruses coming together to form a multicellular organism, and that could be an interesting way to study evolution over time. But that's neither here nor there.
So we think that viruses are the OG multi-celled
Well,
organism.
no. People just I read this very briefly. So the classic origin of multicellular life came from the endosymbiotic theory or endosymbiotic. Yeah, basically one cell ate another cell,
Oh,
and then if you're
cannibalism.
yeah, and then it was able to basically take that cell's machinery and use it for itself. That was the main theory, and then you had multicellular life build off of that. Uh, and then there's two endosymbiotic events because something ate something again, which was even better. They're saying that viruses could be another way to look at it, where you have all these single-celled, I wouldn't say organisms because they're not living, but single-celled things, and that they're working together and could potentially be another way to like look at how life developed. But
Wow.
I like the endosymbiotic theory way too much. I think it's lovely. I think it's exquisitely done. Chef's kiss. And we could talk about that in another episode.
Yeah,
Sure.
I mean, I think about you in all those ways as well.
Like chef's kiss?
Chef's kiss, like you're amazing, you're my favorite,
Oh, oh. You're amazing. You're beautiful.
Yeah,
You're Linda Evangelista. Oh, you won't get the reference.
I don't know that reference, no.
Anyway,
You're an icon,
so
you're a legend, and you are
you
the
are.
moment.
I mean, come
I
on
mean, come
now.
on.
Now you need to simultaneously burp and fart at the same time, and then deny doing both.
Oh,
Oh,
Wendy Williams.
oh
How
God.
is
All
she
right.
still breathing?
They just like pump her full of something and they just push her on stage and they're like, "You do your thing, Wendy." She's like, I gotta fart. Go for it."
No. That one time when she fainted, she just ran out of juice.
Did someone change the battery on Wendy? You know you have to change the battery every day. God.
Oh God.
Anywho, viruses. Back on viruses.
Yeah, yeah.
So those are the characteristics of life. Viruses don't have all of them. They're not living. They're just infectious agents. They infect, cause disease. They're pathogens. That's it. Now, when I was younger, because I'm so old now, I learned the classification system for different viruses, the Baltimore classification system.
Hmm.
Basically, it looked at all these viruses and determines how they make their mRNA. Do you know what mRNA is?
um, mRNA. Let me
Or just
see.
RNA, you don't have to have the M in there. It's fine.
Well, DNA is dino something
Dinosaur?
nucleic acid.
Ooh,
I
ooh, yes.
so R
Deoxyribose nucleic acid.
yes, so RNA is the ribo something.
Ooh, ribose, yes. It's all about what sugar is there. Yeah.
Yeah, and then mRNA is messenger, maybe?
Messenger,
Yeah, see,
yes.
I listened a little bit in bio, a little bit.
Just, yeah, between, just daydreaming, you passively heard some stuff. You
Oh
kept
my
it with
God.
you.
Pat, did I tell you that bio was the only class I've ever gotten a C in my life, ever?
And I'm over here like,
Hey, Mr. See, that's why we compliment each other so much, because you could teach me about the bio stuff that I just ignored when I actually took the class.
and you can teach me about all the math stuff and well,
Yeah.
really the stats stuff. I feel like the
Well,
stats
you
stuff.
know math stuff. You're a math person too. You had a math minor, right?
Yeah. Much like Gates, I did have a minor.
How?
What?
I'm leaving. Goodbye. I'm leaving. I'm leaving the podcast. Here we go.
Okay,
You could
that
do
was
this yourself. You
that
could
was
do
a
this episode
solid.
yourself. I'm leaving.
That was a solid joke. Well, ladies and gentlemen, now that he's gone, let me go.
Imagine I just left the episode.
I would have kept going. This is fine. I would have kept going.
Okay, tell me about viruses. Let's not talk about
Yeah, so
politicians.
we're gonna talk about the classification I learned in Baltimore. There's two classification systems. I know the Baltimore one. I don't know the other one. But Dr. David Baltimore looked at how the viruses made their mRNA, which is messenger RNA, and then he's like, all right, I'm just going to group them up. So now I just want to refresh your memory on the central dogma of biology.
Mm.
The central dogma is that there's DNA, which makes RNA, which makes protein.
Okay. DNA makes
Right?
RNA, makes protein. Okay.
Yeah. So DNA is transcribed into RNA, and then RNA is translated into protein. So that's the central dogma.
Wow.
So he looked at how they made their RNA and classified them as such. So we got 7 groups.
7. Tell them to me.
So group number 1 is a double-stranded DNA virus. So these viruses, their genomes or their DNA is in a double-stranded DNA genome, much like ours is double-stranded DNA.
Right.
So there are 2 strands, they complement each other, and they're like this. Or they're tied up. Yeah, they're like this, really. Yes.
Like 2 bottoms trying to fuck,
Okay. I make the Gates joke and I'm canceled. I'm trying to show you the the gist of DNA, and you're like, bottoms. So double-stranded DNA viruses are group one. They follow the usual, DNA, RNA to protein business, so that's just their group. And adenoviruses are in this group. Adenoviruses are the ones that cause a lot of colds.
Hmm.
So that's your double-stranded. So group two is single-stranded DNA. So they are just one strand of DNA. That's their genome. They enter the host and they actually form double-stranded DNA, and then they use that for all of their RNA protein business. Why they don't
Girl.
go back to double-stranded for their genome, I have no idea. I'm not a virologist, but parvovirus is in this group. The canine infecting, animal infecting viruses. They are single-stranded DNA. Then group three is double-stranded RNA. So instead of DNA as their genome, they have RNA, which is weird. But
Oh.
that's just how viruses are. They're creepy and they're freaky.
Mm.
They basically use their RNA to generate more RNA, and then that'll generate protein. So they have no DNA whatsoever. And rotaviruses are in group three, and these are responsible for a lot of diarrhea.
Oh,
They're called
amazing.
diarrheal diseases. So I guess they're just shitting constantly if you have a rotavirus.
Right.
And then there's group four, which we will get back to later. But group four is they're called positive sense single-stranded RNA. Okay. So you had your double-stranded DNA and your single-stranded DNA, fine. And then you had your double-stranded RNA. Now we're going to have single-stranded RNA. It could either
Okay.
be positive or negative sense. So here's the deal.
Here's the deal. Tell me.
When you have your DNA, it's like this. Or
Right.
really, like let's just like that, right?
Yeah.
Double-stranded. And then
For
when
our
you make
podcast
RNA,
listeners, you're just making two
it's like a
arms.
ladder. It's like a ladder. Think of DNA like a ladder. When you make RNA, the ladder has to unwind, right?
Right.
And then your RNA is complementary to whatever strand of DNA is being used to make the RNA. Now, one of them is called like the coding strand or the non-coding strand or like the sense, and then which would generate sense or antisense RNA. So the differences between them aren't really relevant right now. It's just that if you have positive sense or a negative sense or antisense, antisense, positive sense, sense, antisense, whatever it is, the only thing that's going to change is the intermediate step that the RNA takes to get to proteins, basically. So group four is positive sense single-stranded RNA. So their RNA is already mRNA, basically. They can make proteins immediately from it.
Wow.
So they're primed and ready to go. And this is actually the group that coronaviruses is in. So
Ooh.
coronaviruses
Ooh.
are not a new virus, by the way, in case anyone is wondering. They just call it
What?
the novel coronavirus because this particular virus is new in humans. But there are many coronaviruses. Many of them infect humans, many of them affect other animals. And they are positive sense single-strand RNA, and we will get back to them later
All right.
to have a little discussion about them. But group five is, of course, the opposite, which is negative sense single-stranded RNA. So while your positive sense can be used for protein production immediately, the negative sense has to then generate the positive sense first. So
Oh, okay.
basically, the single-stranded negative sense has to copy itself to positive sense, and then it can use that for mRNA. Why it does this, I have no fucking idea. I mean, I was just like, why not just be all positive? It doesn't matter. But it's just like another intermediary step, and then from that positive strand, it'll make more negative strands for its own proliferation of more viruses. And the influenza and Ebola viruses are in this group, so they are negative sense
Ooh.
RNAs.
So here's a
Um,
question for you.
yeah,
Once they have the mRNA and they make the
yeah,
proteins, which is what you said they do, right? How does that
yeah.
translate to diseases?
We're gonna get into it afterwards.
Oh, okay. I skipped it far ahead. Okay.
Yeah, because I was looking into it a little bit because different viruses obviously cause different diseases, so
Yeah.
I can't. It's not going to be a catch-all type of thing,
Mm-hmm.
but I will go over it. So now we did our first five groups, and now we're on to groups six and seven. So these are going to be your retroviruses.
Ooh.
Um, I believe they're both retroviruses. Yes, yeah, they're both retroviruses. Okay, so group six is single-stranded RNA with a DNA intermediate.
Oh my.
It's called
Hello.
it's called like plus ssRNA Right. Plus ssRNA DNA. I don't know the nomenclature.
SS. Don't you be bringing some super straights in here.
I
Uh-uh.
thought you were gonna say what's the Nazi thing?
Oh,
Spetsnaz?
yeah,
Well,
that I was going for super straight, but
corporate needs you to find the difference between these two pictures. The SS and the SS.
there's the
Same,
same picture.
same picture. So the
Anywho,
group six RNA viruses or viruses are single-strand RNA with a DNA intermediate. So it comes as an RNA virus, a positive sense. It's then reverse transcribed, which that's why they're called like retroviruses. So it's reverse transcribed back into DNA, and then that DNA is then used to make RNA. Some flip-flopping magic
but
happens,
why?
basically.
Why do that? Why go through all this? Girl, you're just doing inefficient shit now. What's happening?
Well, the thing is, it depends on like their host range, so like what they infect, and also viruses they mutate very often. They sometimes pick up host DNA into their own DNA,
Ooh.
so these things are always changing. So at some point, it gained this ability, and nature was like, hold on to that because that's pretty good.
All right. I mean, the way I see it, it's just making things longer. Like you wake up in the morning, you brush
Feeling
your
like P
teeth.
Diddy.
You what?
Wake up in the morning feeling like P Diddy.
Yeah, the viruses wake up, they feel like P. Diddy, and then they go
They
back to
wake
sleep.
up.
They go back to sleep. They're like, what are you doing?
Oh, we will talk about latent viruses as well, which is them going back to sleep.
Oh my God.
I covered it all, honey. So group six is RNA goes to DNA, which then makes RNA, which makes proteins. Um, this group has HIV in it. So HIV is
Ooh.
a retrovirus. Basically, yeah, the host will have its own protein that transcribes the viral RNA in the nucleus. The viral RNA from the host. Or hold on,
Hold.
my brain shut down. Okay, comes in as RNA, makes DNA, right?
hmm
The virus. Then the DNA actually inserts itself into the host DNA. That's what I
Oh,
forgot.
I never
So
said I
that's
was a nice DNA.
I the next words are yes, sir. Or
Yes.
have you forgotten?
Or have you forgotten?
So yeah, the RNA becomes DNA, which then inserts itself into the host genome. Now I remember. And this is called a provirus now. So the viral DNA is in your DNA. That's what makes this thing terrible.
Oh my.
It just hides out there. And then it somehow senses when you're like weak, and then it cuts itself out, and then it starts producing the proteins and making a lot of viruses.
hmm
There we go. And HIV is in this group. And then the last group is group seven, which is double-stranded DNA with an RNA intermediate. So it still needs some sort of reverse transcriptase nonsense like group six does, but it starts out as DNA and then it forms RNA and then goes back to DNA. Flip
Hello.
flopping. And this is the group that has the hepatitis B virus in it.
Ooh,
So those are the
girl.
basic groups. Obviously, there's more detail, but like I just wanted to give y'all a
Basic
very
basic groups confuses me even more.
I know, but like all you need to know is that all these groups are just broken down to what their genome is made of. So whether it's RNA or DNA, whether it's single-stranded or double-stranded, and then how it makes its mRNA, whether it makes it directly or it has some sort of intermediate step.
Right.
And that's how Dr. Baltimore was able to classify these basically. So he's a cool
Wow.
dude. I like him. So we're gonna just go over two viruses specifically. It's like a case study.
Ooh, okay.
The first, of course, is the coronaviruses. Um, so they cause diseases in mammals and birds and all bunch of shit. And it's usually respiratory infections, which is, obviously COVID is a respiratory problem. But if
Yep.
there are other issues it can cause. So they can cause colds, SARS, MERS, and now COVID-19.
Uh,
So
the freaking common cold though is such an annoying like go away.
I know every year more
Every
cold.
goddamn year. The flu too, like go
The
away.
flu, cold. I saw Mitch McConnell recently.
Oh
Sorry, this is an
no.
aside. He was like, I just found out that the the flu shot is actually less effective than the COVID vaccine. I didn't even know that. Because like the flu shot's like what 50-60% effective, I think, against stopping the
Oh,
flu.
really?
Yeah, because he was like, I want all Republican I think he singled out the men too. I think he was like, men gotta get this vaccine, and we get the flu shot every year. And I just found out the flu shot was only 50% effective. This is even better. That's my terrible Mitch McConnell
Oh my God,
impersonations.
it was kind of good though. Can I say it was kind of good? It was pretty good.
Sure, I'll take gas me up. I don't care.
Oh,
Uh, so yeah, it causes a lot of bad stuff. But basically, they're called coronaviruses because when they looked at these things under an electron micrograph, which is just a way to visualize very small things with electrons, it looks like the corona of the sun, like the outer fire of the sun. It looks like a big
oh,
circle with shit coming off of it, and the
wow.
shit that's coming off of it is all the spike proteins.
Hmm.
Spike proteins are not good. They're the things that the body recognizes or that recognizes host cells and helps it get in. So this is the largest group of RNA viruses. In that group of viruses, they have their club spikes on the surface. They have the circular shape. The earliest report was in the 1920s in chickens. So
Oh,
fuck them chickens.
fuck them. Bacau.
Ultra.
Vulture. No.
So the first human coronavirus was discovered in the late 60s, and then most recently you had SARS-CoV in 2003, which is severe acute respiratory syndrome.
Hmm.
Then you had NL63 in 2003, HKU1 in 2004, MERS-CoV, which is Middle East respiratory syndrome in 2013, and then of course SARS-CoV-2 in
Mi-
2019, which causes COVID-19.
Wait, did you say Middle East?
That's called the Middle East Respiratory Syndrome, MERS.
Ooh,
I don't
we really
like
out here
that.
naming viruses by places, didn't we?
I know I don't like it
Didn't we talk
either.
about? Okay, never mind. Okay.
I think it was because this MERS cove was found mostly in the Middle East, but I'm like, can we just call it SARS?
Yeah,
Like severe. I
can we
don't
call it
know.
something else? Like, what's happening? Okay, whatever.
So the structure I already talked about. You got your big circular capsule or membrane with the spikes on it. So you have your spike protein, which is your S protein, your membrane protein, which is your M protein, and those are like the structural ones that form the shell. And then you have your envelope protein, which are just smaller ones that help form the shell. Uh,
Wow.
but really, we're only worried about the spike protein because that's the one that your body recognizes. That's the one your immune system recognizes, and that's the one you have to be, the vaccine has to help you
Right.
target it, basically. So infection.
Yes.
So you got some virus floating around, someone coughed on you, and you breathed it in.
Oh no, a Karen coughed on me in the shop, right? You know?
God forbid. So the viral particle floats in, gets in your respiratory system. The spike protein hits a cell and it recognizes some sort of component that binds to it. And it enters your cell one of two ways. Either your cell engulfs it, or the membranes fuse and all of the internal parts get dumped into your cell.
Wow.
The great thing about viruses is a lot of times when they're exported, they have lipids on them, and lipids are what make up your cell membrane. So the lipids kind of just mesh together, and you can kind of just get something like a smush,
Ooh.
and
I
all
like
of the viral stuff folds in.
I like how you said, you know what's great about viruses?
Well, okay, because they're really when we I got something to tell you later about herpes. You're gonna love it.
Oh, okay.
So then it
Not on the
goes
podcast or
in
during the podcast.
both. I
Both,
got
okay.
pictures to show you.
Oh
It
my.
gets in and then it does its thing. So it's an RNA virus, so it'll generate shit from its RNA, and then basically it sends its new RNA and proteins to the ER, which is the endoplasmic reticulum. Just think of it as a packaging center.
Oh,
Everything gets packaged up so that new viral particle forms, and then it gets exported through something called the Golgi apparatus or the Golgi body. And that's another packaging distribution thing. So it just basically gets the cell, makes the new virus, puts it into the Golgi, and exports it out of the cell. And then it has its membrane on it, and it goes and it either infects, and then it goes to infect new cells, and then you cough up new ones when you're sick,
right.
obviously.
So it shits out, you know, it shits out a new virus,
Yeah,
and then the virus
yeah,
goes to another cell. Right.
yeah, and then it does the whole thing over again. And that's great. I mean, it's great for the virus, obviously. All it wants to do is proliferate. So when it comes to actually disease symptoms, though, uh, with COVID, it's weird because I keep seeing different reports for different symptoms. Like, obviously, there's the respiratory thing, but then people say it can affect your GI tract. People are saying it's like affecting your brain as well. So I don't know everything,
Hmm.
but I think a lot of times what happens is um, the virus can burst cells because it can just keep proliferating more and more viruses in the cell. It gets full and literally just lyses the cell. So you get cellular damage because it's killing your cells, obviously. But also, it can trigger, like, obviously an immune response because your body's like, what's this shit?
Mm-hmm.
And then you can trigger like a hyperactive immune response. So then you get a lot of inflammation, and that inflammation is good sometimes, but if it's not controlled or if it's overactive, then you get other symptoms like, difficulty breathing or excretions from your lungs. So it could either be like the physical damage that the virus causes by exploding the cells, or it could be your body's response to the virus that's not very targeted, because obviously our body has never seen this before, and that's why none
Right.
of us have any immunity for it. And that's the
Oh
coronavirus.
my.
But I want to talk about herpes now.
Okay. Tell, tell
So
me.
I have herpes simplex 1. Most people do because it's the cold sore herpes,
Mm-hmm.
I don't have herpes simplex 2. That's the genital kind.
Right.
Although you did talk about viral load before, which
Mm.
which made me remember. I'm pretty sure I told you this. When I went to the doctor the first time I had my cold sore, it's like, I'm gonna test you for herpes, but I'm pretty sure it's herpes. I'm like, great. He's like, I'm gonna test you for both. I'm like, great.
Great.
He checked my bits, obviously, and he
Right.
didn't see anything. So he's like, okay, this is probably just oral herpes. So he tested me though, and he's like, your viral load was so high that you tested positive for both. And I'm
Oh.
like, so what is it? He goes, no, it's fine. He's like, because I could. He's like, apparently by the number, he's like, your herpes 1, your oral herpes was so high that it can sometimes cross react with the herpes 2 like test
Right.
because they're very similar viruses. So yeah, I had a huge viral load, if you know what I
Oh
mean,
my Lanta.
ladies,
Oh my
ladies.
Lanta. Lady.
So herpes simplex 1 is a double-stranded DNA virus, like we talked about before. It's a group 1 virus. And I get them very often and I hate them. But this is
Oh.
basically the infection of it all. So someone had herpes and they gave it to me and I need to find them
You
and
need
kill
to
them.
find them, kill them, murder them.
Um, Basically, if you have a cut or a wound and like they have herpes, that got in somehow, we shared drinks or something,
Mm-hmm.
you know, or something.
Oh, oh, hello.
So
Suck on some lollipops, if you know what I'm
so
saying.
these things are latent viruses. So they go to sleep.
Right. And they
What
come
happens is,
back.
and they come back. I hate it. They hang out in your ganglia, like these nerve cells around your mouth. They chill there. And then when you have some sort of disruption, like you have a cut, too much UV, like if you're out in the sun for too long and your skin cells get damaged, um, what happened to me was that I smacked my own lip and I got it swollen and then it got infected because my body was like, you have a problem. And the herpes was like, I have the solution.
Herpes was like, here I
I'm
am.
ready.
Here I am.
So basically, they reside as latent viruses, and then they wake up when you're injured, and they're like, "Well, it's free real estate."
It's free real estate.
So basically, there are two characteristic lifestyles of viruses. These are very general, and these are usually described for bacterial viruses, but I'm going to use them for this because it kind of follows the same way. So you have the lysogenic phase and the lytic phase.
Oh my.
Lysogenic phase, the virus just chills out in your DNA. It does nothing. It just gets replicated whenever your cells replicate. It just fucking relaxes. And then you get damaged, and it's like, I'm awake.
Here
So
I
it
am.
enters the lytic phase where it pulls itself out of your DNA. Or like it pulls itself, from wherever it's hiding. It can sometimes just hide as like a viral capsid or some shit like that because they're weird. And then they make a lot of viruses, and they make so many viruses that your cells obviously burst and then causes damage.
Right.
So for herpes, you get infected, it waits, and then the first symptom is always like tingling or redness or like itchiness. And then if you feel that, you gotta hurry up and jump on it. Because this shit in a day or two is gonna just erupt like
Oh,
Etna or like Vesuvius, just spewing
here I
out.
am. Here I am.
So then it gets
Ectomy.
inflamed, ectomy comes out of your face. You get like these tiny vesicles start to appear. They're like little hard but like that you can kind of see them, like they're almost translucent,
Ooh.
and then they'll coalesce into this big blister that
Oh.
just cracks and sebaceous ulcer fluid comes out of it, and you're highly infectious at this point.
All right,
Don't go
let's
near
let's go
anyone.
ahead and disgust all of our viewers so they stop listening.
And you have an open lesion, and then eventually it scabs, obviously. And even then, you're still infectious, and then it heal over time. And even after that, I think up to a couple weeks after that, you have a closed wound, you're still considered infectious because there's some viruses chilling out.
Hmm.
My favorite thing about this, though, is the medication because it's so cool.
Hello.
So there's a medication called famciclovir. It's a pill, and it's like the moment you feel a symptom, that tingling, you take three, and then you take one a day for 7 days, and this shit just wipes it out.
Wow.
There's also acyclovir, which is another. It's basically the same thing, but it's a cream most of the time, and you apply it to the blisters, and it helps reduce it. But that famciclovir, really, if you catch it early, it's done.
Ooh. But the virus
Basically,
is
what
still
happens?
there though, because it still chills out.
Yeah, it never goes away. Although I will say, studies show that as you get older, the time between blisters becomes longer and longer because your body is
Oh.
more used to it, more used to it. The virus kind of attenuates out. Except for this time, I had two. I had one on each side of the lip. I
Oh
was like,
no.
mm. They were
Hmm.
sisters.
Sisters, twins.
Twins. So the famciclovir basically works because it's uh the chemical or the molecule gets in your body and the viral protein and your own protein start to work on it. They do different reactions to it. And it generates something it's called a guanosine analog. So your DNA has A, T, G, and C, right?
Hmm.
Um, adenosine, cytosine, thymine, guanine. Yes. Yeah.
What?
Yeah. Yeah. So it's four nucleotides in your DNA that make up your DNA. So
Right.
A, T, G, and C. So this is a G analog, meaning it looks like G, but it's not G. The virus can't tell the difference. The virus picks up this analog, tries to put it in its DNA when it's replicating, and that disrupts replication, and it can't replicate, and it can't. I mean, it doesn't die because it's not living, but it basically dies.
Right.
So all of these G's, these imposters, these
Imposters among
imposters
us.
start to hang
Bum bum
out
bum.
in your cells, and the virus starts picking them up thinking it's normal G, but it's not. It incorporates it into its DNA, it breaks the DNA, and it can't replicate, and they are no longer proliferating in your body.
Amazing.
And I love that. I love it's like tainting, it's like poisoning the water and giving it to your enemies. It's like Zeke's spinal fluid.
Gasp! Attack on Titan spoilers.
Oh, right. I should have said that beforehand. Well, when this goes live, I'll tell Anthony not to listen to wherever we're at.
Wherever, 37 minutes in, but we'll
37 minutes in.
we'll tell him. We'll tell him.
Um,
So let me make sure I understand something because I'm still not
yeah.
sure I quite understand it.
Yes,
Um,
yes.
so what causes the infection? I'm going back to coronavirus real quick.
Go
What
for it.
causes like the inflammation and the shortness of breath and whatever is when the virus is trying to replicate and it bursts open cells because there's too much of the virus in the cells, so it bursts open and causes inflammation. Is that right? Am I getting that
Well,
right?
okay. So I don't know because the viruses have lytic and lysogenic lifestyles. They also have other lifestyles such as they replicate but they don't kill the host.
Hmm.
So there's a name for it, but I'm pretty sure coronavirus. I don't know if it's lytic. I don't know if it's bursting the cells. It viruses can, and that's where physical damage comes from. But there's also the viruses that just make just enough viruses to keep growing and keep making more, but not enough to kill their host. I think the inflammation really comes from your body's response to the virus
Ah, okay.
because it doesn't know how to work with it. It doesn't know how to recognize it. So it's just like inflaming everything. It's just sending all of the neutrophils and histamines over there to just inflame it, increase the temperature because your body's like natural response to an invader is to increase the temperature,
Right.
increase the blood flow because it wants to just burn out whatever's in your body. So I think that's really where most of the inflammation comes from. But I'm not a doctor. I
Oh,
mean, plants maybe, not
plants.
humans. But I,
Oh.
I do love virology and the classification system I love, and I do love how they work. There are plant viruses too, tons of plant viruses. There is
Oh.
a cool plant virus. I'm sorry, there's a cool fungal virus that
Oh.
it'll infect the fungus and make it weaker, and it can't be pathogenic to its host anymore. And I'm like, virus is doing the Lord's work.
What does that mean?
So like the virus gets in this fungus somehow, and it made the fungus weaker, so it can't infect, whatever the fungus normally infects.
Oh wow. Isn't there
Work.
like oh my god, isn't there some fungal infections that can like take over the host and like control it?
Oh, yeah, you're talking about those good. You got the zombie wasp, the ants.
Yes.
What is that? It's cordyceps. Cordyceps. Everyone loves writing like the Last of Us game is all about some cordyceps virus fungus that takes over humans. People
Right.
love cordyceps. Yeah,
That
so
sounds scary.
cordyceps basically the spores enter insects. Usually, I think it's only insects they infect. They might infect small mammals. They'll colonize the insect, and usually they force it, like in the case of ants, they force it to climb a large tree, hold on to a twig, and then it germinates. So the spores are so high up that when they're hit by wind, they disperse over large areas. So
Wow.
the insects are just means of dispersal for the fungus.
Oh my. That is scary. That is
Yeah,
scary.
they become very weird, and they start growing the shit out of their heads.
Oh
So
my
it's
god,
like this.
yes.
Oh, I
Oh my
could. We should talk about cordyceps and fungi one day. I love fungi. You know I
Oh
love
my god.
fungi.
Imagine like creating a biological weapon out of these fungal spores that can infect people and take over their minds.
Well,
Oh no.
that's no, it's not real. Don't worry.
Okay, I thought you were gonna tell me, oh, that exists.
That
I
exists
was like,
already. No, I don't think there are any cordyceps that affect humans that like to that extent. There are fungal problems with humans, but usually like these fungal issues are in humans are when humans are immunocompromised or old, which means they're usually immunocompromised because most of the times healthy people our immune systems can readily recognize fungi. So like we don't really worry about it that
right.
much. Like athlete's foot maybe sure, or a yeast infection sure. But those are all topical, really. Your systemic fungal infections, you have to have something wrong with you. You gotta have, like HIV patients often have secondary fungal infections.
Wow.
Yeah.
And for the rest of our listeners who are curious, because I'm also curious.
Oh,
So when you get the coronavirus vaccine,
yeah.
it's basically helping you create the spike protein, or like what is it? An antibody that will recognize the spike protein of the coronavirus, right?
Well, it gives your body the mRNA to make the spike protein. The spike protein enters your body, and then your body starts making antibodies from the spike protein because the spike protein is not infectious.
Right.
Spike protein can't do anything by itself. So everyone needs to chill. It's not going to kill you. It's just the spike protein. Now, I saw something very interesting with female fertility.
Ooh.
Some people think that the vaccine is going to cause female infertility because they think that the antibody for the spike protein will also recognize a female uterine, like egg, ova protein.
Oh.
So they think that the antibody would target the woman's reproductive component, whether it's the ova or the uterus, I don't know what, and then you wouldn't be able to give birth anymore. That's been like debunked because the spike protein and that protein are not similar enough for cross reactivity.
Hmm.
And B, if that were true, women who've had COVID would also be infertile because they would have already generated antibodies from the spike protein, which have already attacked their, uterus, whatever.
Right.
So that's just false flags. I just want to get that out there. But yeah,
That's
the
misinformation trying to
mRNA
be spread out here.
it is, and I will have none of it. But the mRNA makes the spike protein. Your body recognizes spike protein after it builds up an immune response to it through antibodies.
Yeah, and then I was watching a TikTok,
Me
which
too.
may not be the best place of gathering information, but I was watching a TikTok on why we need the booster shot. Is because our immune system will see the mRNA for the spike protein, right? And it will be like, okay, let me make some antibodies, but like this is the first time I'm encountering this infection, so maybe it's not that bad. And then
Yes.
it encounters it the second time. It's like, oh shit, I should really like make more antibodies because this is the second time now
Yeah.
I'm seeing it.
I think that's the logic with all boosters is that your body's your body's immune memory, genetic memory, it needs to be like refreshed,
Yeah.
and it needs to have a certain level of response to when it sees it. So I think after your first shot, your body's response is there. It's just not to the level that you would need to be safe from it. So you need that booster shot, unless you're getting obviously the the Johnson and Johnson one, which is a one-shot one.
Yeah.
But that might have to do with the how much antibodies you're getting from that first shot. Because if you're getting a lot from that first shot, then obviously you wouldn't need the booster. But mRNA is RNAs are very easily degradable. So I'm wondering when you get the mRNA virus, how much of the mRNA just fucking bleh?
Bleh, goodbye.
Eukaryotic RNA is more stable than prokaryotic RNA, but like it's still weak. It's feeble.
Well, I'll tell you, Pat. Today's March 3rd, 2021. In case anyone's listening to this in the future,
March 3rd?
April 3rd. Sorry, April 3rd.
Okay.
Today's April 3rd, 2021. Right. I got the shot, the first one of the Moderna vaccine, this past Wednesday. Just went by. I didn't have like any side effects. None, except my arm hurt. That was it.
Yeah.
We'll see after the second shot though, which I'll get in a couple weeks. But yeah, I didn't have any side effects.
I've heard the second shot, people do get a little sick for like a day or like, 2 days, they get a little meh. But I'm telling you, once Monday comes around and I'm eligible, I'm gonna
Get right in there.
I'm gonna stalk those pages. I'm gonna get in there. I'm gonna get my shot.
Oh, get shot up, boy.
And then, get my second shot and be fine because
It'll
I
be
trust
fine.
science.
I trust. God. All right. We're 46 minutes in. Did you have any other words for us?
No, I mean, the only thing I want to say about viruses is, in particular the coronavirus, is that there is some suspicion that there might be a fourth wave of, infections. Because a lot of people are kind of they were on spring break or there's like relaxed things like in fucking Texas and shit like that.
Yeah.
Just so people be safe until you get your vaccine, both vaccines, shots, whatever you get, until you're fully vaccinated, just be safe. Like, don't. We're almost done. Like, we're almost done with this. Like, can we just chill and wait, and then when we're really done, we can have our.
Yeah, really. Just hit like the next 2-3 months. Just relax.
You can last another 2-3 months. Like we've been doing this over a year already. You can last another 2-3 months without fucking it up with everyone
just
else,
chill.
please.
Like just chill, and then everyone get vaccinated, and we'll be all good.
Because I know I'm being an alarmist, but it only takes one really good mutant, one spike protein that has shifted significantly enough, and these vaccines are gonna be bleh.
Bleh.
The current variant's great. The vaccine still protects it, but if it just gets slightly out of that area, we're like right back in it.
Done and done skis.
Yeah, so but that's it.
Oh, good chat, Pat. Good chat. I really appreciate the educational.
Oh well, Matt was flaming me. Matt was like, "You don't do educational stuff enough anymore."
I never said that. That string of words did not come out of my mouth. This is what I said. I was like, Pat, like, we haven't done an educational one in a while. And I was like, okay, so I'm going to do one. That's what I did last week. I did the proof by example one. I did more educational one. I never said, Pat, you're a terrible person for not doing an educational one anymore.
I didn't say that either. Oh, okay. Sure.
You bitch. All right.
Sure.
We're going to call it there. Thanks, everybody, for watching this episode of What Do the Gays Think? If you don't follow us on Twitter, go ahead and give us a follow there. We retweet a whole bunch of stuff. Right now, our account's kind of like a little Nas X Stan account, so come follow us there at WDTGT Podcast. Link is in the bio as well. Link is in the description. We haven't actually streamed on Twitch in a while. March has been a pretty busy month, but we hope to get back to it. Our Twitch is What Do the Gamers Think? GAYMERS. What do the gamers think? And yeah, if you're on any podcast platform, go ahead and leave us a rating. We really appreciate that. And if you're on the YouTube, you can go ahead and subscribe and also like and comment. We'll see you and get back to you. Anything else, Pat?
No, that's it.
Great. So that's it then. I am Mac Lupek.
And I'm riddled with herpes, Patrick.
Okay. Goodbye.
Bye.